Hi, physics. Mr. Janowski here. This is the second part of the chapter 32 slides. So, to review, what two ways to add vectors did we learn last year? There's the parallelogram way. I should stop calling it parallelogram rule. It's not a rule. And the tip to tail way or method. So, yeah, these are both graphical ways of adding vectors. What is the algebraic way of adding vectors that we learned last class? That would be using unit vectors. So unit vectors are the things with the I hats and the j hats. Again, I hat is the unit vector in the x direction. So it's unit, mean it's 1. It's got a magnitude of 1 in the x direction. And j hat is a magnitude of 1 in the y direction. So yeah, this is how we add the vectors. Express them as, in their components, has something I hat plus something j hat. And then to add them up, excuse me, to add them up, just line up all the I hat terms, add them all straight down, line up all the j hat terms, add them all straight down, and then you get this. So besides unit vector notation, what is the other type of notation we learned last class? That would be the angle notation. So in unit vector notation, you're giving the components of the vector. So 4i hat is the x component, and minus 4j hat is the y component. If you're using angle notation, the way you write it is you give the magnitude first, and then you give the angle at which that vector is, and then finally the units. So question 4, when using angle notation, how do we express the angle? You measure from the positive x-axis, and you go counterclockwise. So you go around this way. So this vector we're looking at here, you could call the angle that it's at either 315 degrees, if you're going around counterclockwise, or you could call it negative 45 degrees. So yeah, always measure counterclockwise from the positive x-axis. So in the first part, we learned things about charge. We learned Coulomb's law for figuring out the force between two charges. In the second part, we learned, I guess that makes this the third part of the slides. I don't know what the hell's going on. In the next part, we learned about unit vectors and doing things with that. So now we're going to put them together. So in this situation, we have 4 charges, Q1, Q2, Q3, and Q4. All of them are 1.25 microcoulomb charges. They're all positive charges, and they're all sitting on the corners of a square with sides 0.250 meters. So what is the net force on charge Q, on charge Q3, in angle notation? So we're trying to figure out what's the total force that the other 3 are going to be putting on this guy, and we want it in angle notation. So how do we do this? First, we're going to find the force that each one of the charges exerts on Q3. Then we're going to express it in unit vector notation, so I hats and j hats. Then we're going to add them up, and adding forces in unit vector notation is fun and easy. And then finally, we're going to use Pythagoras and inverse trig to switch from unit vector notation to angle notation. So the gist of this is, when you're adding things up, add them up in unit vector notation. And then if you need your final answer in angle notation like we need here, then you do a step 0, basically. You use Pythagoras and inverse trig to figure out the angle of the thing. So if we're doing this, let's start with what is the force Q2 is exerting on Q3. You plug it all into Coulomb's law. We've got 2 positive charges, so they will repel, which means Q2 is going to push up on Q3. So this is the number that we get, 0.2247 newtons. And the fact that it's up makes it very easy to express in unit vector notation. So this is all something j hat newtons. There's no I hat component to this one. So convince yourself, if we're going to figure out the force from Q4 on Q3, it's going to be the same magnitude of force. It's the same, amount of charge, the same distance away, just, in a different direction. And if these are both positive charges, which they are, Q4 is going to push Q3 to the right. So when you write it in unit vector notation, you get this one. So we've done Q2 and Q4. Now to do Q1. Q1 is the tricky one, because look, it's going to be pushing up and at an angle. And we need to figure out what the force is. So how do we do this? First, use the Pythagorean theorem. Figure out what this distance is. So you've got that. After you know this distance, you can use Coulomb's law to find the magnitude of the force of 1 on 3. Then you've got to do trig to figure out the components of that force, because it's going to be up and at an angle. We need to figure out how much of it is to the right, how much of it is to the up. And then finally, we want to express the components together in unit vector notation. So Pythagorean theorem gives us this, just 0.250 meters squared plus 0.250 meters squared gives you the hypotenuse squared. You take the square root, you get this. And then plug that into Coulomb's law. That gives us this force. So the little green arrow here, it's not as big as the other ones because it's the same amount of charge, but it's further away. So now we have that one. Now we have to use trig to find the components of this. So in this case, it was fairly easy. It's fairly obvious that it's going to be at a 45-degree angle, which made this not so very difficult. But we started with this force. Again, here's our force, 0.1124 newtons. We needed to find the components of that force. How much of that is to the right? How much of that is to the up? So you do that. You have your components. You express it in unit vector notation. Now we have to add all of these forces up, which is very easy to do once you have them in unit vector notation. Just line up the I hats, line up the j hats, add them both down. So we have this. So now we have the total force on charge 3. We have it in unit vector notation. Now remember, we're looking for this ultimately in angle notation. So we're going to have to do some work from here. And let me point out at this stage as well that this that we're looking at here is a step 1. This is a sketch. What that means is this is a picture of where the things actually are. And on a sketch, distances are distances. So you go some amount to the right, well, you've gone a distance to the right. That's what a sketch is. So again, here we are. Force on Q3, this is the total force. I probably should have a sigma here. The sum of the forces on Q3 is this in I hat and j hat notation. So now we need to use a step 0 to get the magnitude. So we knew the components. The components are this, 0.3042 I hat, so that many newtons to the right, plus 0.3042 j hat, that many newtons up. So you've got to do Pythagoras to figure out this magnitude right here. We now have a right triangle. So we have the magnitude. Now, if this last image was a step 1, this is a sketch. This is showing you where things are, and distances are distances on a sketch. This is a step 0. These are components. This is more abstract because your distances here are not distances. If you go a certain amount to the right here, well, that's an amount of newtons. That's not a distance. So it's a step 0. That's what's going on here. Anyhow, Pythagoras gave us this magnitude here. So we need the angle. Now, in this case, it should be fairly obvious that this is a 45, 45, 90 right triangle. So the angle is pretty easy to do. If that were not the case, you would have to do this using some inverse trig. And I did it using inverse tangent. So I knew this component, the opposite. I knew this component, the adjacent. So I did the inverse tangent, and I figured out that this was a 45-degree angle, which I knew anyway. So yeah, here, FQ3 is equal to I hat plus j hat. That's your unit vector way. And we did all this work. We turned that into an expression for the force on charge 3 in angle notation. So here is your magnitude, and here is your angle. And that's it for this part. So this stuff is tricky. Hopefully you were able to follow along with this. My advice is you really have to do the problems. You have to get your hands dirty by doing these things. So there's so many little pitfalls. You watch the videos. You watch the problem videos. Hopefully this was helpful.